Use induction to prove that 15 to the power n minus 3 to the power n is divisible by 12 for all positive values or positive integer values of n. So as with induction proofs, what we do is, we need to first prove it is true for n equals 1, then it's true for n equals k, where k is a positive integer, and then it's true for n equals k plus 1. So that's what we will do. So we assume that fn, function fn is 15 to the power n minus 3 to the power n, and suppose n is 1, so then it would be 15 minus 3, that's 12, so it is divisible by 12, obviously. And then if n equals k, so let the statement be true for n equals k, then you would have it as 15 to the power k minus 3 to the power k. And this is divisible by 12. That's what we are assuming. So it's divisible by 12. And since it is divisible by 12, we can write 15 to the power k minus 3 to the power k is equal to 12m, where m is a positive integer. So the next step would be to prove that this statement is true for n equals k plus 1. I don't know why did I write all that, but what I meant to say is n equals k plus 1. So if n equals k plus 1, then fk plus 1 would be 15 to the power k plus 1 minus 3 to the power k plus 1. And you see, we can write this as 15 to the power k times 15 minus 3 to the power k times 3. I think this is the most important step here to proving that this statement is true for n equals k plus 1. So you break it down, 15 to the power k times 15 minus 3 to the power k times 3. And then this 15, I can write it as 12 plus 3. So it will be 12 plus 3 times 15 to the power k and minus 3 times 3 to the power k. So we remove the brackets and we get 12 times 15 to the power k plus 3 times 15 to the power k minus 3 times 3 to the power k. So then I can write 12 times 15 to the power k. This remains as it is. And then I group the two terms here. So 3 outside the bracket, I would have 15 to the power k minus 3 to the power k. Now you see this 15 to the power k minus 3 to the power k is nothing but 12m. So then I think we already have it. 12 times 15 to the power k plus 3 times 12m. So then you take 12 outside the bracket, 15 to the power k plus 3m. So this is a multiple of 12. And so we can say that fk plus 1 is also divisible by 12. So the statement holds true when n equals k plus 1. So I can write here that statement holds true when n equals k plus 1, and hence proved.